Hello class, in this video we look at the sampling distribution of standard deviation. Assume a population of 3, 5, and 10. The size of the population is 3. The population has 3 elements. Normally the population has very large size. Just for the convenience here, this population only has 3 elements, 3 values, 3, 5, and 10. Assume that samples of size 2 are randomly selected with replacement. This guaranteeing independent from the population. Listed below are the 9 different samples. Complete part A through part D below. So we have 9 samples with size 2. The first sample 3, 3, and then 3, 5. So those are samples, by the way. It's just the sample size very small. The sample is very small size, only has 3 elements in it. So the first part, we want to find the population standard deviation. Part A is to find the sigma. The population has 3 elements, x1, x2, x3. We can either use the formula. The formula is xi minus x bar. You have to find the sample mean first, which is 3 plus 5 plus 10 divided by 3 is 6. And then to the power of 2. And then add them together and then divide by n here. All right. So that formula, this formula is for population standard deviation. N here has to be 3. N here is the denominator. Let's see, the value we got is around 2.944. Is equal to 2.944. You can use the TID for calculator for sure. You put 3, 5, 10 in the list 1 and then use one variable stats to find the sigma sub x. All right. So for the first part, we find the population standard deviation for this population. And the second part, we need to find the standard deviation for all the 9 samples. That's a lot of work, right? I know that. And then we have to create the probability distribution for those standard deviation. So let's do one at a time. We have 9 samples. As we can see, I'm going to use different color scheme. This one, and this one. Those 3 samples are going to have sample standard deviation equals 0 because, you know, standard deviation describe the dispersion of the values, right? The values are the same in the sample. So the sample standard deviation is going to be 0. The yellow one, this one, S is 0, S is 0, S is 0. And then let's change it, different color. Let's say green. 3, 5, 5, 3. Those two should have the same standard deviation. You can manually to calculate the sample standard deviation. The formula for sample standard deviation is xi minus x bar to the power of 2, and then take the sum and then divide by n minus 1. So here is going to be size n. Sample size n is 2. 2 minus 1 is 1. So here you're gonna have 1 and then take the square root. So be aware. Population standard deviation and sample standard deviation have different formula. The difference is the denominator. You can also use TID for calculator to find a sample. Here, I have the value for 3553 in the calculator. I'm gonna just write this down. Is a 1.414, okay, after rounded, 1.414 is around equal to 1.414, the 2 green samples. and change another color, let's say blue. 3, 10, 10, 3. They should have the same, because they are the same sample, actually. And the standard deviation, you can use a formula or you can use the TI-84 calculator. I'll just tell you the value. It's, I think it's around 4.9. Let me double check. 4.95. 4.95. 4.95. This one, 4.95. And two more, right? Let's use pink. Sample 5, 5, sample 510 and the sample 10.5. They are the same sample, you know. So they of course have the same standard deviation, sample standard deviation. The value is about equal to 3.536. All right. So finding the sample standard deviations for all the 9 samples, all the 9 samples. If we use which variable? That's x. Yeah, let x be the variable that represent the sample size, the sample standard deviation. Actually, let's use capital S. Let S be the variable that represent the sample standard deviation with size 2, right? Then we have the following possible values for S. We have the following possible values for S. S could be 0. Look at the 3 yellow samples. S could be 1.414, 1.414 for the 2 greens, right? It could also assume a value 3.536 for the 2 pinks, and also could assume value 4.95. So they are all the possible values. They are all the possible values for this random variable S. So do you guys try to figure out what is P32? P32. Actually, not P32, my bad. So if we try to use 3 by 3 equals 9, yeah, because with replacement. So those 9 samples actually are all the possible samples of size 2 we can get from the population. And that guarantees those values 0, 1.414, 3.536, and 4.95 are all the possible values for S, which represent the sample standard deviation of the samples with size 2 from the population. Okay, what's the probability? We are creating the probability distribution table for the random variable S here. And then we have 9 samples in total, right? And the yellow 3, so 3 over 9 is a classical model. 3 over 9 is 1 over 3. And 1.414 appears twice, is a green color, 2 over 9. Same with the pink and the blue. And so this is the probability distribution table for the random variable S, which represent the sample standard deviation of samples of size 2 from the given population. I know it's a very long sentence, right? And part C is to find the expected value of S. the expected value of the random variable also can be seen as the mean of the random variable, right? So how do we find the expected value for the random variable s? We multiply the value of the random variable with the corresponding probability. Remember that? So 0 times 1/3 is 0. And here 1.414 times 2 over 9. Here we have 3.536 times 2 over 9. You can also use calculator, TID for calculator, right? And then you can, or you just doing it manually, 4.95 times 2 over 9. And then you're going to add them together. Okay, add those values together. And I can tell you my result here is 2.2. Is 2.2. Since the mean of all those sample standard deviations is not very close to the population standard deviation, which is 2.944. Not very close. 2.2 is the mean of all the sample standard deviations of the samples with the size 2. It's not very close. So we say is not targeted to the population standard deviation. So we can conclude here. The sample standard deviation do not target the population standard deviation. So sample standard deviation is not an unbiased estimator. It is biased estimator. All right, I hope this helps.